So one of the keys, as we saw with that example of the electric vehicles, your cars, your trucks, even your classics being electrified, it's really driving a big change. And it's one area that we feel is very important to focus on in terms of the electrification. What we're actually seeing is that the value in the vehicle will be shifting from the chassis and drivetrain to the electronics and sensors, to the point where estimates have it at 50% of the value of the vehicle being in electronics as we move in towards over the next decade here. So what are some of the challenges that this will bring? So in terms of the electrical content, we're really focusing on your printed circuit board assemblies and your wire harnesses that are connecting the vehicle. And it's often seen as a black box. Limited visibility into the costs associated with those, and the processes in terms of working with suppliers are by no means optimized. The components themselves are a significant cost contributor. They're constantly changing. You have issues with life cycles. You have variability in terms of cost based on demand, and information that's typically stored in a variety of places, if managed at all. And when we look at costs, there's an issue in terms of understanding the entire vehicle and the electromechanical aspects of that. So being able to understand the costs of, we've been talking over the past 2 days here with, all the capabilities to simulate your mechanical processes. Well, if for completeness, you really need to be able to consider the electrical components as well, and take that into consideration to really have a full roll-up. So with aPriori, in terms of electronics cost management, we have a very robust solution for costing PCBAs and wire harnesses that allow for very quick analysis, consistency across the different teams or users that'll be analyzing them, and providing the details in terms of the components themselves, as well as the transformation costs in the build process. And really, this is by digitizing the process, it's helping to enable engineering to make early decisions prior to going out and quoting and having insight to be able to respond quicker to their customers. The contract manufacturers to be able to respond very quickly and consistently to quotes and ensure that they're hitting their target margins. And for the OEs to really form more strategic relationships with suppliers, that transparency that Daniel just spoke about in terms of the Harman presentation, where it's critical that you're able to work closely with your suppliers, but also ensure that it's a win-win on both sides, and that you're able to negotiate and make sure everybody is aligned. With this solution, we saw in a session earlier today where Stephanie Mills covered our solution in depth and covered demonstrations. We're powered and partnered with Silicon Expert, which allows us to consolidate and get accurate real-time cost information and physical property information on the components that ultimately drive and help that roll-up of the cost be pulled together and consistent across all users. And that gets coupled with comprehensive manufacturing process coverage, from initial prep processes all the way through testing and integration of your printed circuit board assemblies and your wire harnesses. So just to touch upon electrification in some of the key aspects of the solution, if you wanted to go back and look at the recording, that would be very helpful for you. So let's talk a little bit about lightweighting. So it was interesting in the video we saw with the 67 fastback from Charged Cars, there was a mention of pulling several hundred kilos out of the car by using carbon fiber panels for the deck lid, the hood, and the fenders on that vehicle, to do a couple of things: enhance performance, potentially extend range with electric vehicles. Pulling weight out of it is a way to get additional miles or kilometers out of the vehicle. And it applies as well to your internal combustion engines, where you get increased fuel economy. And of course, the performance benefits in terms of acceleration. With internal combustion engines, you can only get so much out of horsepower, and you get a better payback potentially by pulling weight out of the vehicle, and the performance characteristics and handling can all be enhanced. So certainly some benefits there. So what are some of the approaches to lightweighting? So a few key things to do is potentially look at alternate materials or alternate processes. So as we saw with charge there, the use of composites is, vehicles are containing various levels, but it's in conjunction with other materials. So aluminums, high strength steels, titaniums, magnesiums, it's actually changing a lot about the vehicle, not only the individual parts themselves, but the way they're joined in the manufacturing processes. There's adhesives being used, there's self-piercing rivets. We look at a vehicle like the Ford F-150, when that went all aluminum, it really drove a lot of changes and some uncertainty about those changes in materials. An alternate way is to look at the process. So we see more and more activity in the area of additive. We have, processes around composites, looking at, multi-component sheet metal assemblies, and potentially that could be a casting, for example. So various ways of looking at different processes to, help with overall part quality, pulling weight out of the part, and also potentially driving some cost out of the vehicle. The question is, how do you evaluate the costs of all these alternatives? So let's take a look at an example here of a liftgate assembly. This is an assembly that, early design has been completed on, and there was a request that came through from the Dynamics group looking to pull 3 kilograms out of this assembly. Well, one way to start to think about this is possibly changing the material. Instead of a steel lift gate, potentially it could be changed to aluminum. Well, how long would that take cost engineering group to go through that analysis and return the updated costs? And what if there was a supplier involved and you had to go through the RFQ process to really understand how much it's going to cost you potentially to drive those 3 kilograms out of the design? Well, with aPriori, we went through the analysis. Of course, the CAD work has to be done. The gauge of the aluminum was thickened up. There was assembly process changes to move away from a spot welding process to some adhesives. And this was analyzed, and we can quickly see that we've gone from 12.29 kilograms down to 9.07. So we actually hit the mass target, and we can see what that's going to cost us. And actually, there was a cost associated with that, but we were able to go through that analysis in a matter of minutes or hours versus days and weeks. So to be able to help provide informed decisions, you can leverage the capabilities here for doing that. Another way, let's look at an example here of an individual component that is ready to be released, goes through stress analysis with successful results coming back through, and then it goes out for RFQ. And there's this time spent waiting, only to find out that it's come back and the price is just unacceptable. It's way too expensive. So redesign activities occur. So geometry is modified, removed some material, reanalyzed in CAE to make sure that it structurally is still sound, and then back through the RFQ process and waiting again. So all that time waiting is really is not helping in terms of getting to an optimized design. So what if you could use that time to get through another iteration? The problem is that with the compressed time to market and the chart that Craig showed earlier on, where your development cycles have compressed, time is really of the essence. And you need to be able to work under those pressures. Waiting on supplier feedback and RFQs, that's just another bottleneck in the process. So with aPriori, we can quickly go through those that analysis. Designers can use that extra time in terms of waiting on RFQ responses only to find out that it's too expensive. Several weeks can be wasted, where that time could have been spent further optimizing the design, driving out weight and cost from the design. So in this case here, there was an additional weight reduction as well as a cost reduction by getting that extra cycle in. So continuing on that theme of compressed schedules and really how processes can potentially evolve to take advantage of digital threads and the capabilities that a digital solution can provide. There's opportunities for sure in terms of market share. We see, as Craig put up, with all of the new vehicle entrants coming in, getting to market first gives you a big competitive advantage. However, you still need to be able to make sure that you're hitting profitability targets. Looking at the new technologies and exploiting them, we looked at materials and processes. There's uncertainty and risk associated with them. So how do you provide the insights to really understand that manufacturing process and the costs associated with it so that you can get the most out of those new technologies that you're adopting? And going back again to working with the supply chain, looking at, is this going to be made internally or is it going to be outsourced? And establishing those partnerships with transparency with your suppliers, just exactly what Daniel was talking about with the Harman use case, and how you can have transparency to make it a win-win on both sides. So what are the barriers to optimizing this development process from the earliest stages of concept design to getting the vehicle out and delivered to the end user? Well, one bottleneck that we see is inefficient design collaboration. There's a lot of people and a lot of groups within the organization involved, and even extending out to the suppliers. Lots of iteration and back and forth that there's opportunity to improve. Manufacturing issues, having those come up after the fact and trying to, scramble to not only, process very costly ECOs that in some cases, $5,000 for an ECO is not unheard of by any means, but in such a compressed time frame, you're not at liberty to deal with issues that come up and just extend the process. So being able to address ECOs early on and make sure that you're hitting cost targets. The time to go back and perform VAVE activities is limited in order to maximize productivity in such a compressed schedule. And make sure that those supplier relationships, the struggles that are there in terms of the lack of transparency, and in many cases, we see that quote packages go out to suppliers that are not well suited for them, are not necessarily going to even potentially be bid on or bid completely on, and it puts undue stress on the suppliers having to respond to those. So if we look at what we can do about this whole thing and really transform the process, it's looking at the digital twin and what could you do if you could leverage the digital twin to analyze parts for cost and manufacturability very early on upon design and check into your PLM system. Look at the parts and identify the issues on those parts from a design to cost and a design for manufacturability standpoint so that you have insight into where you stand from a target cost, and that those manufacturability issues that are driving cost or are going to result in an ECO can be identified early on, being able to highlight those features in the cost drivers and provide some guidance for how to fix them so that the designer can go in, work on just the parts that need to be addressed and make those changes in CAD and make the updates, and then get the right information to the right people at the right time. So consumers in manufacturing, in sourcing, cost engineering, and even the supply base having the right information to really help accelerate the process, eliminate the bottlenecks related to communication, and provide the right information to take the right decisions to optimize the vehicle. So our solution, we've seen this different presentations throughout the course of the couple of days, and really lots of traction, and really being able to drive adoption in engineering to provide that cost and visibility is really enabled by our Cost Insight Generate solution that allows the design engineer to check models into PLM, have the cost and manufacturability analysis happen in the background, information passed back to the main repository in PLM. So your cost information, manufacturability scores, and then get that information to the design engineer so that they can go address the parts in question, work interactively with the CAD system, and focus on what's important. And with all of that said, with the challenges of electrification, lightweighting, the need to address the compressing schedule, it's really all about embracing the digital thread and digital manufacturing to adapt to these changes. So making sure that you can meet those aggressive schedules with a digitally transformed development process, achieving target costs, avoiding manufacturability issues early, minimizing the risks associated with those unknowns, and finally, enabling the collaboration across the enterprise, leveraging the digital twin. So that's what we see as the ultimate way to really change the way that vehicles are developed today, to really take advantage of the digitalization, to bring more insight early on in the process.